Hello bachcho, I welcome you all to this new series in which we are going to discuss advanced JEE problems which were asked in physics. So this is the first problem which was asked in JEE Advanced 2023. So let's read this problem. A bar of mass m 1 kg and length L 0.2 meter is lying on a horizontal frictionless surface. One end of the bar is pivoted at a point about which it is free to rotate. A small mass m 0.10 kg is moving on the same horizontal surface with 5 meter per second speed on the same path perpendicular to the bar. It hits the bar at a distance L by 2 from the pivoted end and returns back on the same path with speed v. After this elastic collision, the bar rotates with an angular velocity omega. So we have to find this angular velocity omega with which the bar will rotate after this elastic collision. So if you try to understand this problem clearly, you will get to know that there is a concept which is going to act in this problem, and that is conservation of angular momentum. So let us first draw the diagram involved in this problem. So this is the pivoted end through which a bar is hinged, and this bar is of mass 1 kg and length 0.2 meter, and this lies on a horizontal frictionless surface. Now there is a mass which strikes. So this is a mass small m and it is going with some initial velocity, let's say u, and it strikes to the middle point of this, because it is saying that it strikes at L by 2 from the pivoted end. So it strikes at the middle point, and after the collision this mass returns back with some velocity, let's say v. Okay, so what is the initial angular momentum of the system? So initial angular momentum of the system will be angular momentum of the mass small m plus angular momentum of the rod. Because the rod is at rest initially, so it will not have any angular momentum over the point O. Okay, so we will write the angular momentum initially. It is equal to m v r, and that is m initial velocity is u and r is L by 2. So this is the first or initial angular momentum of the system. Now we will write the angular momentum of the system after the collision. So angular momentum of the system after collision will be angular momentum due to the m mass and angular momentum of the rod. So we'll write the angular momentum of rod as I omega, and angular momentum of the mass will be minus mvr. Why it is so? Because it has changed its direction of motion. So it will be equal to I omega minus mvl by 2. So these are the two angular momentum. Now we can equate L initial is equal to L final. So we'll have mu L by 2, that is equal to ml square by 3 into omega, because the moment of inertia of the rod about this point O will be ml square by 3 into omega minus m v into L by 2. So we will have m u plus m v. Okay, and we can take 3 here and 2 over here. So m L into omega, isn't it? So because I can take 2 out of here and multiply it here. So 2 ml and take L out of the equation. So this will be our first equation. Now we also know in elastic collision the kinetic energy of the system remains conserved. So the initial kinetic energy of the system must be equal to the final kinetic energy. Now what is the initial kinetic energy? Due to the small mass, half of mu square. And what is the final kinetic energy of the system? Half of mv square plus half of the rotational kinetic energy of the rod, half of I omega square. So we can take 2 out of the equation, and mu square minus mv square, that must be equal to ml square by 3 into omega square, and we can take 3 over here. So this is the second equation. So on solving these two equations, we will get the value of omega and the value of v. I'm going to write the value of omega, which you have to calculate by solving these two equations, and the omega will come out to be as 6.98 radian per second. Okay, so you just have to solve this equation and comment whether you get the answer or not in the comment section. If you like the lecture, please subscribe the channel and comment me on which another topic you want me to create lessons, and we will continue this question series as well. Okay, till then, have a great day.